So let's go ahead and run through this example. I will actually take this out because this was just me showing you a quick example of how the older way was working. So I'm going to take it out. And now let's actually go ahead to program, and I will create, or rather initialize, the pattern matching class and then run through it. So let's do that quickly and then use pattern matching instance and run from it. I forgot the semicolon, so I will put that there. I put a dot there instead. So this should be good to go now. Now let's go here and see where we should put a breakpoint. I'll put it there. So run. And these are from the previous example, so don't worry about that. Now let's see what's going on. So you're creating a normal person and a super person. They both have angry as true. Now let's go into the break wall with normal person. And this will step into it. And now we're saying, so see, person, but it says it's a normal person. So here we can check that. It says, is the person normal person or a super person? It's going to be a normal person and it's going to be angry. So that should say true. So let's see if that works. Yes, it did. And then it's just going to go through the rest of it. I actually close it up, so let me just run it again. But that, through the normal person, is going to say broke wall, which makes sense. For the super person, going to do the same. Obviously, in this case, it's just saying that it's a super person instead of a normal person, but it's going to pass the condition because it is going to be true. So that also makes sense. Now, let me stop this real quick and let me make normal person false. It's not going to be angry. Let's see what happens then. So when I run through this, it's going to do its thing. And let me actually stop it and rerun it because I went a bit too far. And here it's false, so we know that. Now we're going to step into it and let's see what happens. So the person is a normal person and it's not angry. That means that this condition will not be matched. It's going to cast it to normal person, but then this condition will not match. So then that means we will not come here. We should go here. Let's see if our expectation is true. Exactly. That didn't match. So it's going to go here and then get out of there. And so it's going to say wall didn't break. For the other one, which is a super person, it says wall broke. Okay. So now let's check out what can you break method, which is the switch case with when conditionals. I'm going to go inside, and in this case, person is a normal person. So it's going to say didn't match any of these, but it did match this. So it's a normal person, and it says cannot break stone wall because that person is not angry. And then it's going to go and break. And then for the super person, it's going to, guess what? It's going to come here and says it's super person. Is it angry? Yes, it is true. And it's going to say it can break stone wall and titanium wall. So that's going to work. And then, actually, let's just turn this false as well so you can see the difference. I'll rerun it again. So, we've already gone through the normal person and the super person. So I'm going to skip this one, just run over it. For the super person, let's see what happens. In this case, it doesn't really care if it's angry or not. As long as it's a super person, it's going to pass. So that's still true. That's fine for this guy. And then we're going to go into what can you break. Step into it. Normal person, we've already gone over this. Gonna say, well, it's a normal person. That's cool. And see that? The reason why I didn't match this because it's not angry. So it didn't match this. It just then went to a more general case. Is it a normal person at all? Yes, then just print this. So that worked. And then the super person, let's see. It's right here. So it's going to say super person because it's not angry. The when did not match the condition. See? Going to break, come outside. Now here's the interesting part. When it's a null that you're passing in, Now, since you can pass in custom types, switch now can have a case statement for null, because it's saying, listen, whenever this is being casted, so if it's a person and it's not null and it's super person, that's the only time that this is going to match up. If it's a null, then it doesn't matter. It's obviously not a super person. So then it's not going to match anything. And if you have a default statement, it's going to just fall back on that. But if you also want to catch null cases, then you can have a specific case for nulls. In this case, you're saying the wall will not. So actually, let me run through it. And it's going to say the wall will stay as it is since nobody will be hitting it. So the wall will stay as it is since nobody will be hitting it. And that's because the case was null. It's going to break. And obviously, if you pass something in that it doesn't know how to handle, let's say there's another class that is inheriting from the person and you're passing that into the switch statement, then it won't know, it doesn't have any cases for that. So it's going to fall back on the default. And you can put the default anywhere that you want, because in this case, the order doesn't matter for the default, but the order matters for the case statements. So I hope that this gave you a nice overview, because this is really what, pattern matching helps you to do. It helps you shorten out the checking of the type and then casting of the type. So you can do it in one line. And then once that is the case, then you can extract values out of that variable. In this case, this guy, right? So you're creating an alias and then putting that casted value into that variable. And then you can use properties from that variable. So that's a very helpful feature, and C# 7 and on is going to add more to pattern matching. So there's a lot more fun things to do, and all those updates are going to come down to the pipeline, and I will be making more examples about that as already mentioned. But that's it for now.